right? So if you have gone through the, I mean, if you have got the session plan, so this should be a session about motion detection and alarm systems, right? So uh, I just want to create this session rather interactive session, right? Without just delivering the delivering the content. I want to get answers from you, right? So just be ready with that. And I mean, there's nothing to be scared or anything. So just give you ideas about the things that I asked you. Okay. So actually, I can't see the participants when I'm sharing the screen. So it's good if you can change your names uh, with the class that you're in. And if you can rename yourselves uh, with the class, I can get a proper idea of the crowd here, right? Yeah. Okay, let's just continue. Okay, so uh, before going into the core content of the today's lesson, that is motion detection and alarm systems, I was just thinking about giving you some sort of a background idea of what these things are without going into the thing straight away. So I have prepared a few slides regarding the background actually. So what are these automation systems, and I mean everything that you create, everything that you learn during these sessions, they come under automation. So what is basic automation? We just talk about it. So before that, before even commenting on these automation systems, I would like to ask you, I mean, if you are joining, like, since you have joined here, you might have some sort of an interest towards engineering, right? Creating new things, working with robots, and maybe those things. So, what is the core purpose of being an engineer or doing some kind of an engineering stuff, right? So, do you have any idea? I mean, I can see the people here. Uh, if somebody can unmute yourself and just give me what is the core idea, core purpose of being an engineer? What do you expect uh, from an engineer, or what do you need to do when you become an engineer? Just if you can give me some sort of an idea. Yes, don't worry, don't be scared. There is no right or wrong answer. So just I need your ideas. I mean, if you can unmute yourself, that is better, or else you can just pop it in the chat. Yeah. Mm. Yeah. So creating something for the betterment of the society. Yeah, that is one thing, right? So creating something, that is the core idea of being an engineer. Creating something. So creating, what is creating? That using your existing knowledge in order to make something. So making things, making new things, developing the world, that is done by engineers. So that is the core idea of being an engineer. So as one person correctly mentioned, it is creating things. So that is the first thing, I mean the main thing that an engineer should target, like without using or maybe without maintaining the stuff that is already there in the world. If you can create things, that is the purpose of becoming an engineer. Okay, so just for your background knowledge, I will just go through some things around about engineering, because that's my uh, piece of cake, right? So I'll just impart some sort of a knowledge around that as well. So if you take engineering, so if I, yeah, so if you take this field of engineering, this is divided into several parts. So uh, at a glance, you will see that engineers are all the same, but it's not. You have different parts of engineering. You have different fields under this vast field called engineering. So one thing is you find out electronic and maybe telecom is also there. So this is a huge part of the things I just explained about it. So everything you use in your day-to-day life, the mobile phones, tablets, maybe computers, or anything else that compose of an electronic component. So that comes under electronic engineering. And also telecommunication is something that we use every day. But is it the main thing is making calls, right? So telecom. That is also a huge part of engineering, that is electronic and telecom. And just briefing. So these are some deep topics that I might not go into the deep details of this. So that is okay, just for your idea, just for your knowledge. So then you have computer science. Computer science is all about software, maybe computer related hardware, those stuff. They come under computer science engineering. So making a software, making apps, making websites, and also maintaining systems for certain tasks. So those come under computer science engineering. That is also a very a very common kind of engineering that you find out in the current world. So these AI and all those things come under the computer science engineering. So these computer scientists are the people who build these AI and everything. So we are just using it. But scientists and engineers, computer scientists and engineers are the people who build up these AI and stuff like that. So then you might have electrical engineers. So that is a very important thing that you have to have in your daily life. Without electricity, you cannot do anything. So electrical engineer, that is also very important part under engineering. So the power distribution, transmission, so those come under this electrical engineering. Okay, then mechanical engineer. So this is one of the core engineering fields. I mean, if you think about an engineer, you might think of machines or maybe cars. So those people come under the mechanical engineering field. So this is one of very interesting areas on the engineering. So automobiles, aeroplanes, ships, and also on the other hand, large machinery. So these everything come under the mechanical engineering field. So if you want to become a hands-on engineer, I mean that make your hands dirty under engineering, so you can choose mechanical engineering. Right. So then you have several stuff. Civil engineering. So that is also one thing, the one main thing, building these houses, apartments, and many construct roads. So these constructions are done by civil engineers. And also you have chemical chemical engineering, material science. This is also one of the uh, prominent engineering fields that you may find out in the current world. So without materials, we cannot do anything. I mean, without anything, we can do it. So everything is made up of materials. So the analysis of materials is done under this material science engineering. So these are few engineering fields that you may come across. I mean, having knowledge about these things might help you in the long run. I mean, don't need to by heart or remember anything. Just have them in your mind that some things like these are also there. Right. So enough of these things. I will just go into the uh, details about the automated system. Right. So in the word itself, automated systems. What is the purpose of automated system? Why do we need automation systems? The main purpose of automated system is there in the word itself. That means making something uh, automated. Automatically, you have to carry out some kind of a process. So that is the whole purpose of automated system. I mean, if you want to write down anything, you can put some notes, right? Have some notes. There, I will try to share the slides as well. If something is important, if you feel that something is worth writing off, you can just take that. Okay. Then, why do we need automation systems? Uh, the main purpose, as I told you, automating something, reducing the influence of people or reducing the interaction of people into some sort of process is automation. So what is the purpose? Increases efficiency and productivity. That is very obvious that if you involve people for everything, for every task that you come across inside something, some process, if you involve people, people might be lazy at times. People might be talking with other people. They have, I mean, they might have their own problems even. So the that might be a sort of a hindrance in you consider the whole system. So when you use an automation system, increasing efficiency and productivity is some kind of a prominent advantage. So it increases efficiency and productivity. Then reduces human error. So humans are fond of making errors, right? Uh, so that errors might be, I mean, there might be some sort of an error. Like you cannot entirely get the human out of the system, right? If some person is there, there might be a chance of having an error. So, but reduces the human error. Then enhances safety and reliability. So safety is a key factor that you have to consider in some sort of a system. If you take a large factory, there's a very big chance of having accidents due to this heavy machinery and all sorts of things, and maybe electrical hazards may be there. So that might be some sort of risk to human beings. So that risk is also reduced by using automation systems. That is enhancing safety and reliability is that we can trust on machines more than humans. Like humans may be making errors, their work might not be consistent. So therefore, using some sort of a machinery might be more reliable in some cases when you consider a system. So if you have any doubts or if the lesson is getting bored or something, just ask questions or maybe I don't know, anything. Right. So saves time and energy. That is obvious. If people are involved in everything, they might take uh, more time and energy as well. So using machines, you can reduce them. Okay. So where can we use an automated system? So you can see these automated systems in many day-to-day applications in the present world. So smart homes, you may have heard. So smart lighting, security systems. These are some prominent day-to-day activities that we use automated systems. And industrial automation is a very huge topic that is basically using automated things, maybe robots, maybe robots or anything in the factories. So in the industries is known as industrial automation. This is a huge topic, right? This is a huge topic that if you have an interest, just you can go through the internet and find more information about them. Then automotive systems. So that is also some kind of a vast area, vehicles, cars, and various other land vehicles, air vehicles, maybe aeroplanes or ships or anything. So there is a huge part that is being automated in those stuff as well. So if you take a car or maybe a passenger car in the current world, you might see automated cars, that means self-driving cars. So those all are results of what? Automated system. Then you have healthcare, agriculture, and things like that. Okay, so that is the automated system that we are talking about. Why are we talking about the automated system? Because we are going to learn these things and learn the things that we learn in cybots in order to make something, make some process automated. That is the whole purpose of having these sessions. I mean, the primary purpose is imparting some sort of a knowledge to you, but at last, at the end of the day, using that knowledge, you will do something. You will do a project. So maybe a project that will help the people to do certain tasks. So basically, that is automation. Uh, Knowingly or unknowingly, we are driving towards automation by doing these sessions as well. Right. So as I told you, you will be developing some kind of a project at the end of these sessions. So this project is not Like, it's not just building something. There should be a formal way of entering into a project. So if I just brief through it, these are some wide topics. I am just briefing it to you just for the idea that these might be helpful in some way. So when developing a project, when developing some kind of a product using these sensors, actuators, and all, so you might be familiar by them now. Uh, First thing is problem identification. So this is the entry of a project. So you have to have a problem to solve. Without a problem, I mean, what are you making? What is the purpose of making something without a problem? You have to have something. You have to have purpose of your project. So that is the first thing. Problem identity. For example, if I say that, just take some example, uh, some day-to-day activity. Let's say you have some food to be preserved. You have to have some food to be preserved. So that is the problem. So this is a very basic thing. What you have? You have the refrigerator. Think that refrigerators are not yet invented. So you are the engineer thinking for a solution, how to keep food, how to preserve food for maybe a couple of days. So that is the problem. What is the problem? Preserve food. Preserve food. So that is a problem. Like, this could be a problem that had been arising in the past. So that is the reason they have invented the reflex. Okay, that's the problem. So you correctly identify the problem. You need to preserve food, and there is no way that you can do that. Then you have to plan. What are the possible solutions that you can give? What are the steps that you can take to solve the problem? So that is the planning process. So the slide say design, approach, resources, and timeline. So in the planning process, you have to have the resources allocated. So in order to preserve food, you will have to manufacture or make some kind of an instrument that you can put the food inside it and keep a couple of days. So this gadget, this equipment is the thing that you want to create. So you have to have some sort of resources. Resources in the sense, this might be many things. First thing, hardware resources. What are hardware resources? The sensors, the enclosures, maybe enclosures are the outer covering of the refrigerator. Hardware, I mean the sensors, enclosures, maybe electronic, other wires and stuff like that. Powers, power supply, maybe if you are using electricity or something else. So that should be one resource. Okay, so those are hardware resources. Then you might require something else. For this resources, now who is going to make this? This refrigerator should be made by someone. I mean, uh, just because you have resources, you have some sensors or something, automatically you cannot build a refrigerator. You have to have some sort of a person or maybe a group of people, a team to build this. So that is people, or maybe we call it labor. So this is a resource. So that resource should be there. And also you have to have time. I mean, you have to have a timeline. At the end of this day, you are doing something, some sort of work like this. At the end of a week, you are completing this part. At the end of the month, you are completing it. And maybe within 2 months, you have to complete the entire project. So there should be a timeline. So time is a very important resource that you'll be encountering in a project. And then the capital. Without this, you can't do anything. Capital means money. So you need to buy stuff. You need to hire people. So because of that, you need capital. So these are few resources. I mean, there are more. There are more. Uh, I'm just explaining briefly about these facts. So hardware, people, uh, capital, and also time. Right. Then you have to design your product. Design in the sense you have to find out exactly what you're using and what you're combining. So in this case, uh, planning process should be there. So you have to maybe model the refrigerator or maybe draw the wiring diagrams, something like that. So you have to design your product without actually building it. You have to design it on paper, right? Or maybe in software or something like that. So that is the design process. And then implementation. Implementation is building the actual product. So this is the most important uh, Yeah, I'd say this is the most important part. So building up the project or maybe the product that you are planning for is the implementation step. So at the end of the implementation, you will have some sort of a physical product on your hand. Then you have to do testing. So I'm just making the slides dirty, don't worry. So then fifth one or the next step is testing. Not all products work the way you want in the first time. So you have to fight with it. You have to mm, make the things perfect. So that is testing. So you have to input several conditions, maybe uh, several working conditions. So by testing, only you get the right product at the end of the project. So testing is also a very important stage of the product development. Then you have to finalize. Finalization is the same. You have to present it to the customer or maybe your mentor or somebody. So there should be a presentation process. So you have to explain the things, explain the features of your product. I mean, if you are the one who made the project, made the product, you only know how it works. You only know what to use. You only know the maintenance process. So that is not the method. If this product is being used by somebody, that user should know in and out of the product. So that is the finalization or maybe the presentation or that is also some sort of a marketing. So that presentation part should also be there in the project development life cycle. Okay, I hope these things are kind of clear. I mean, these are off topic, but this should be important at some stage of your career, maybe not in the project or maybe in the later stages of your this thing. Right. Okay. If you have any doubts, just ask me. That is okay. I will give you around 30 seconds to grasp this. And if you have any doubts, you can just unmute yourself. Yeah. Huh. So there's a question, right? How do automated systems make decisions? Do they follow fixed rules? Okay. So there's a good question. How do automated systems make decisions? Do they follow fixed rules or can they learn over time? So there is a, I mean, that is a two-way, there is a two-way answer for that. So one is fixed solution. As you correctly mentioned, there's a sort of product, there's a category of product that gives fixed solution. And also it can learn over time. Some products can learn over time. So this is the trend that we are going forward in the current world. Now this, if I explain you about the fixed solution, let's say mm, maybe a conventional refrigerator. In the same example, I'm taking conventional, that means traditional, or maybe the refrigerators that you find out maybe in 2005 kind of years, 2005, 2008, or maybe those years you had this refrigerator. That refrigerator is a box. It just cools the stuff inside it. That is a fixed solution. Might be you can change the temperature back to in 2000, back in 2005. Yeah, might be there. It gives some sort of a fixed solution. You can put food. You can uh, uh, give a certain temperature on that, and that is it. That is it. That is the whole purpose of the refrigerator. But now, the current refrigerators, you have several stuff. I mean, let's say there is a fridge. It has the ability to off its cooling when it's not needed. In this one, in the conventional refrigerator, it's 24 hours, it's on, and it might consume a lot of power. Even food is there or not, if the refrigerator is plugged in, it will run. But if the refrigerator is learning over time, he can sense the food inside the refrigerator, or maybe he can sense the time of the day. Let's see the use of this refrigerator comes on around 6, and this time, but before maybe around 5. No, let's see, like person is coming to his home around 6, and he eats something inside the refrigerator at 6:30. Let's say hypothetically there is a fridge. There's a refrigerator. I don't know if it is actually there. I'm just giving an example. This fridge has learned that the fridge knows that the user is coming home around 6 and he eats something at around 6:30. In the conventional refrigerator, as soon as he comes home, he should keep the food out of the refrigerator because with that temperature you cannot have it, right? But in the uh, this refrigerator, the new modern refrigerator, if he has known that the person comes home at 6, he will just slow down the cooling, increase the temperature and make the food in a consumable format. So then just he can come at 6:30 and have the get the food out of the refrigerator and eat it. So that is some sort of learning. What the machine has learned, what the refrigerator has learned, the time of the day. He knows that the fridge knows that the person is coming around 6. So I should reduce the coldness of the food. I should make the food to be eatable, edible, right? So that is some sort of a learning. So there are, I think you got the answer for your question. So there are machines, there are products that give fixed solution, and also on the other hand, uh, in the current world, you may find out several products that learn things over time and give customized or maybe personalized solutions. Right. Okay. I think you got the answer for your question. Yeah. Okay. Right. Right. Okay. Right. So in the now we are going to move into the lesson of the day. Sensors used in motion detection and alarm system. So what is our topic for today? It's motion detection and alarm system. If somebody can, I am asking a question. If somebody can explain what a sensor is used for, just put it in the chat or anything. I mean, don't call me sir, right? Don't call me sir. It's okay. It's okay. Okay. So I want to get the answer from you. What is a sensor used for? What do you mean by a sensor? What is it used for? What do you think? Why do you need a sensor? Just think. Sensor. That also you have the answer in the word sensor. Sensor. Something that sense, right? Something, some sort of equipment, piece of electronic component that sense something. Okay. So what is the sensor used for? To gather information from the environment. To gather information from the environment. That is the purpose of a sensor. That is how the computer or maybe the product or the machine perceives what the conditions in the environment are. So that is the use of a sensor. So in terms of motion detection and alarm systems, there should be a sensor to detect the motion, right? So that is the core purpose of having a sensor in this context. Motion detection sensors should be used, right? So I have just listed out few sensors that are used for motion detection. First thing is PIR. What is it? PIR sensor. Okay. Passive infrared sensor. So that is the name of it, not name of it. Uh, this one. This one is the PIR sensor. PIR sensor. So what it does is detects infrared radiation from human body heat. Right. So this is very important. Uh, this PIR sensor sends something. Uh, no. I will just skip it. We have that in the next slide. Okay, so we have PIR sensor. Then you have something called ultrasonic sensor. Ultrasonic. So ultrasonic is sound waves. You might know it. Ultrasonic is the sound. So it uses some kind of a sound wave to perceive the motion. Then you have infrared. So the early one is passive infrared sensor, and you have the third one that is infrared sensor. So this is active. This uses IR transmitter and receiver. So this is the IR sensor. So this is one of the two bulbs. You might see it's some sort of a bulb. So one is the transmitter and another is the receiver, receiving the IR ray, IR radiation, infrared radiation. So this can be used to detect motion, uh, and it can be used in several stuff like motion detection of entry systems, maybe doorways or something like that. So that is a IR. I'm not going into deep stuff of this. Just I'm touching the surface level stuff. If you have the interest, just go to the internet and just play around with these things. Just buy the components if you can. So just have some experience with them as well. Okay. So this one, camera based sensor. So this is something that is trending these days with the AI and image recognition and stuff like that, image processing. These camera based sensors are widely used today in, if I just say some examples, in self-driving cars to perceive self-driving cars to perceive the environment, perceive who is crossing the road, what are the obstacles in front. So camera sensors are used to perceive them. So this is a very accurate thing. It's like the eyes of a human being. Then used in advanced surveillance systems, maybe camera surveillance systems are security systems. Uh, okay, so we talked about PIR sensor, passive infrared, then ultrasonic, infrared, and also camera sensors. So this is the camera sensor. This is a camera here. It's a camera. And this one is the ultrasonic sensor. So okay, I think everything is clear up to now. Yeah, sort of. Okay. Then we are coming into the passive infrared sensor. This is the component that we are talking about. This is a PIR sensor. For the sensors, if I say all the sensors you might come across in your projects, maybe in the industry also, people use in several serious stuff. So those sensors are named using a code. So using that code, you can just find its data sheets. I'm just giving you some keywords. Just note them down and see what are they. See what these things are. Data sheets. So uh, by knowing the name of the sensor, like this HCSR501, so you know that this is exactly the sensor that we are talking about, and you can just go to the internet, get the data sheet, and see the specifications of them. So why do we see the specification? To see whether that sensor is required, I mean, that is suited for your requirement. So just note down the stuff I'm telling and just go through them later. Right. So the thing I wanted to say is you have a specific name for each sensor. So if you can remember the names of the sensor, that will be easy for you to work with them or maybe explain it to somebody or maybe when buying the stuff. Uh, Knowing that name is some sort of a necessary requirement. Okay, so the PIS sensor name goes as HCSR501. Right. Then concept of a PIR sensor. So what is the concept of this? PIR sensors detect changes in IR radiation. IR radiation is infrared. That is basically that is nothing but heat. Heat, right? So this is a sensor that detects changes in heat. Now, how does it affect the motion? I mean, how does it sense the motion of something by considering the heat? So if you take a person, a human being, this person's temperature is around 37 degrees Celsius. But if you consider something surrounding him, let's say a table, a chair, or anything, a cupboard, or something like that. So these are stuff you find in the environment that does not have a temperature closer to human temperature, right? So then there is a possibility to detect a person inside a room or maybe inside a space by detecting the changes of the temperature around the object. So this block, I mean this person will use a different color. This person has a different temperature from the rest of the object. So this is clearly identified, clearly distinguished. So if you see the temperature thing is moving, I mean if you take a room, if you take a room, everything else is having a cold temperature. But there's a thing. I don't know. It's a human or maybe an animal also. Because they also have some sort of a body temperature. This thing is moving. At one point it's here. At the other point it's here. So that motion is detected by the temperature difference. So at a time, this area's temperature is something else. I mean, it's increased. So in another moment, this area's temperature is increased. So if you can detect the changes in temperature, you can find the motion. If that part is not clear, just let me know. Just let me know. Put in the chat. Yeah. Okay. The then so that is the concept behind the PIR sensor. That is the whole concept. Then working principle. That is this thing might be at thing that you may find advanced, but it's okay. I will just go through it. PIR sensor contains a pyroelectric material. So this one, don't no need to remember anything. Just keep in mind there are certain things called pyroelectric materials. These will induce a current change, an electrical signal change with the difference with the changes in temperature in the surrounding. So these are some high level things. I mean that's good for knowledge. I'm not just touching on them deeply, right? Yeah. So I think the concept and the working principle of a PIR is okay with you. Then I'm just going into the next one. So the earlier part is somewhat simplified in this slide. So passive infrared sensors, how is motion detected from a PIR with a passive infrared? Now environment emits steady IR. So if there's a person, if there's a man, if there's a man, this one continuously emits IR radiation. That is a heat. It's a continuous generation or maybe continuous emission of heat. Then there is no change. I mean, if it continuously gives the heat around the sensor, there is no change in heat. There is no output signal. There is nothing to detect actually. The things are all right. Things are as it is. Now, when a person moves across the sensor field, the IR pattern changes. That's what I told you earlier. In a certain time, uh, that heated object is here. In the next moment, it's here. So there is a change in the pattern of the in the IR pattern. So that is detectable by the sensor, and the sensor detects this change. Electrical signals are generated using the sensor. Then the signal is processed and the motion is detected. So that is the very simplest form of the PIR that I can explain it to you. Right. So that is okay. I think that's okay. Yeah. Just take around 30 seconds to grasp the thing. If you want, you can ask some question or anything. No question. Any question? Any idea? Is it going? Okay. Right. Okay. So let's move to the next part. So now this is the place that you have to understand carefully, and it's the most important part of handling a sensor. There is the connection and also the coding part. Now, connection is simple. It's very simple. You have to just grab the wires, connect it to the PIR, and then connect the corresponding wire to the slot of the Arduino board. That is simple. That is okay. The main part is the code. So this code, I'm not going through the code line by line. I'm just opening it up for you to go through it. I'll just explain. So then we say the sensor output is yeah. If I tell you the core idea of the code, you can just go through the syntax later. I'm not explaining the syntax. That's not work. So if I just tell you the core idea of the code, it's like this. If you get a signal, if you get an electrical signal from the sensor, that means possibly there might be a change in the IR field around the sensor. So then you produce something to the sensor, and the electrical signal changes, and it is given to the controller. So the controller decides that there is something, and it informs the user that an object is detected, or maybe some motion is detected. So that is the key idea. If I could say to you the motion change is there, then it is as a result of the motion, there's a change in the IR pattern, change in the IR pattern. Then sensor electrical signal changes. That means this will now here onward is the code. This will give whether 1 or 0 to the controller. Here is the controller, that's the Arduino board. Then it decides motion or not. Don't worry, my handwriting is very beautiful. It's okay. So motion or not. So this is the path. So this will happen in the environment. So as a result, the sensor produces the same. It gives some sort of a 1 or 0 or maybe a signal to the controller, and the controller may decide whether there is a motion happening or not. And it will display to the user. Display. Right. So that is the core idea of the code. Just go through the code. If you have any doubts, start me. Okay. Right. Okay. Then that is the story about passive inferred sensor. Then we are going into the next sensor that we are talking about today, ultrasonic sensors. Right. So this is a very, very simple sensor that you might find in almost all the projects that you will try to handle in the future. So ultrasonic sensor uses sound. So ultrasonic, that is basically sound. This sensor uses sound to manipulate the object detection. Now, concept of an ultrasonic sensor use high frequency sound waves. High frequency, that is why they are called ultrasonic sensor to detect objects. Then, mm, yeah, then it's operated based on the echo reflection principle. So let's see what this is in detail in the later slides. Then the working principle is the sensor has two main parts, the transmitter and the receiver. The transmitter is this one, and the receiver is this one. So one transmits wave, and the other one collects, receives the wave. And using some sort of a calculation, let's see what the calculation is in the later side. The object is detected, and maybe the length to the object, the distance to the object can also be detected. Right. So that is the working principle. It's easier. It's easier than the IR sensor because IR sensor uses some sort of a material that's pyroelectric material to perceive the heat and all. So this sensor, ultrasonic sensor, is a lot more easier to use. And the code of this one, I mean not the code, the product code, the sensor code of this one is HCSR04. This is the name of the sensor. So you can identify the sensor. If somebody says I'm using HCSR04 sensor, you have to know that it's a ultrasonic sensor. Likewise. Okay. So then, how is motion detected from an ultrasonic sensor? The sensor emits a pulse of ultrasonic sound waves. The waves travel through the air and hit an object. Waves are reflected to the sensor. The sensor measures the time taken, echo time. Distance is calculated using the speed of sound. So, this is basically uh, sending something and it hits the obstacle. Now the object is detected, hits the obstacle, and it reflects back. It collects, and then it measures the time for the transmitting and receiving process. Then, using something, it can decide on the distance where the object is. So that is basically the working principle or how the motion is detected from an ultrasonic sensor. I think that is okay with you. If you have any questions, just tell me, or maybe put in the chat, or you can just raise your hand. That is also fine. Right. Okay. Then now the calculation part comes. Distance calculation with the ultrasonic sensor. Now I said this sensor, if I show you the sensor, this the sensor is there and the obstacle is here. Now this is the transmitter, is the receiver. The obstacle is here. This one, the transmitter transmits a wave and it receives the receiver receives that wave. What happens is, let's say uh, at the time of transmission, you measure the time. Let's say time is it's 0, it's degree 0. Then at the point of receiving, let's say you have taken time of t for the process of transmitting up to receiving. A time of t has been taken, right? Time t is taken. Then we know that this is a what? A sound wave. This is a sound wave. This is a sound wave, that means this travels to the obstacle with the speed of sound. That one is a known data, that is basically around 340 meter, meters per second. So these are few technical stuff that you might find later. Don't worry about it. If you don't understand, just tell me. I will explain once more. Uh, so you have the speed of sound. Then you know that the time taken is t and speed of sound is this. What is the missing thing? That is the distance. So that is the thing we are saying, distance to the obstacle. That is the obstacle. Distance to obstacle. How to find the distance? You have the time, you have the speed. Now the distance, the wave travels twice the distance. Can you see that one? The wave goes to the obstacle and it returns from the obstacle. So actually, in the actual terms, it has taken only half the time. So for one way, the wave gets only t over 2 time to reach the obstacle. Then we know that the time we have to use is this, right? Then how to find the distance? Distance is, speed times time. So distance you will have to find it. Speed, it's 340 or maybe 330 or something like that. Time is that t by 2. So using this one, you can find out the distance between the sensor and the obstacle. That means basically you can find that there is some sort of an obstacle, and even you can get the distance to that obstacle as well from the ultrasonic sensor. Is that part clear? It might be a bit difficult. Just tell me if you want to. Alright. Okay. Okay. I'll come to the question. Yeah. So before that, just tell me the core principle of that is understood by you. Just just go through it. I'll give you around 1 minute. Yeah. I think things clear. Oh, I will afraid to ask questions on the assumption that everything is clear and moving forward. Moving forward in the sense, I'm taking that question. What is that question? How does temperature affect the accuracy of an ultrasonic sensor? That is a good question actually. How does temperature affect the accuracy of an ultrasonic sensor? Now, why this temperature is there? In the earlier case, PIR sensor detects some sort of a temperature in heat and all. So that temperature thing is related related directly to PIR sensor. But that question is an important question, as I said. How does it connect with ultrasonic sensor? Now, the main point that bridges temperature with the ultrasonic sensor is the speed of sound. Speed of sound. Why that is happening? Why that's happening? With the surrounding temperature, the speed of sound might change. Then what happens? This 340 cannot be used as RCCS. You have to measure the speed of sound at that temperature. Then you have to use that value in your calculation and read out in the system. You have to constantly feed the speed of sound to that. Otherwise, the accuracy of the ultrasonic sensor will be doubtful, right? So that is the thing you have with the temperature, the surrounding temperature, and also the accuracy of the ultrasonic sensor. I hope it's clear, right? I think it's clear. If you have any other questions, just let me know. Yes. Okay. 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 Right. Now, moving on to this one. Now, this is the main part. As I said earlier, also the code and the connection. Now, how to connect the Arduino? Connect this thing ultrasonic sensor with the Arduino. So you have 4 pins. You call these things these parts pins. You have 4 pins in the ultrasonic sensor. One is the VCC, trig, and echo, and the other one is the ground pin. So this VCC and ground are used for power. The VCC pin is basically you have to connect to 5 volt, and the ground to ground pin that you find out in the Arduino board The trigger and echo pin corresponds to the transmission and receiving of the signal. So those should be connected to two different pins of the Arduino board, and the signal can be manipulated by the code. Right. I hope the connection part is clear. I hope the connection part is clear. Then if you go to the code, right, it's a simple code, but the concept around the code is the thing I mentioned here, this one, right? So basically, the input that is given to the system or the controller by this sensor is a time delay, right? That's the time delay. Then you have to use the time delay appropriately in order to find the distance. Yeah, duration is the thing that is obtained from the sensor. That is the sensor reading. If I say it more correctly, sensor reading is the duration. That is the gap between the transmission and receiving. Then that is known as the duration, and that duration is divided by 2, as I correctly mentioned in the previous slide. Uh, then this 0.034 is the conversion of the speed of sound. That is 340. The unit conversion has given some additional decimal places. Don't think about it. That is the speed of sound. So this is more or less similar to the equation that I gave you in the previous slide. So that part is included inside the code. So you can see that this code is not something changing with the environmental conditions. So this is a hard code. Like this 0.034 is hard coded. Now if you are using the sensor in different temperatures, constantly changing or rapidly changing temperature, this thing should not be the same. So there is actually an issue, as one said correctly, with the temperature of the surrounding. So then you calculate the distance and display the distance to the user, right? So that is it. Any questions regarding the connection part and the code? Yeah, thank you. Right. So let's move into the hands-on project. This is something that we apply the things we learned up to now. So we just discussed about sensors, some connection, some code, but we didn't use it, right? We just discussed the working principle, uh, so and so, but we didn't really uh, discuss about the usage or the application of it. So now we are going to look into the application of the sensor that we were discussing earlier. Right. So this is the hands-on project. So now the project is a PIR security system. So if I just briefly introduce what this system is, this project is a simple security system designed to detect human motion using a PIR sensor that we discussed. Uh, when movement is detected within its range, the system activates an alarm using a buzzer and LED indicators. Uh, Now the purpose, if I just explain the purpose of this project uses the PIR sensor to detect a human motion. So that is the whole purpose of the project, and that is the application that we are trying to apply the sensors into. Right. Then, so what are we going to do here? What are the things that we require to do the project? First thing is you need to have a microcontroller, that is Arduino Uno or maybe Arduino Nano. We have things called Arduino Nano in Mega or something like that. So you need to have a microphone. If it's not there, the brain of your project is not there. That is the whole main part of the project. Then obviously you have to have a PIR motion sensor. That is the sensor of the product. Then buzzer. Now what is this buzzer thing? This is the buzzer we are talking about. Buzzer. Why it is used for? That is the actuator. Now another one is the actuator. That is the actuator that activates from the reading of the sensor. So reading is obtained from the sensor. The controller decides what the things are and what the things that should be done. And the actuator is the person. Actuator is the thing that conducts the activity. So here, in this case, the buzzer sounds. So it will give you a warning sound that there is a human motion or some sort of a motion around this thing, right? So this thing is the actuator. And also there's a light LED. So that is also acting as some sort of an actuator here. Those two things indicate the user that some sort of a motion has been happening, has been there, right? Okay. Then you have to have resistor, a breadboard, jumper wires, and power supply. So power supply is also another important. Otherwise, you can power up the Arduino, power up the sensor. The power supply, maybe you can use batteries or maybe what is the battery? Power bank. So those things can be used. So these are the things you have to have in the project. So now I'm not telling you how to do the project. So you have the problem here. So this is the problem as I mentioned in the first few slides. So the problem is clear, and I have come to a later step. I mean, I've helped you. So there are you have the resources, or maybe this is the model of the planning part, half of the planning part, deciding on the resources. Now, from that point onwards, you have to uh, carry on the project. So the problem is there, the things that you require for the project is there. You just have to write the code. So the writing the code is not a big issue these days. You can just use the AI tools you have, but before using them, uh, construct the logic by yourself. I mean, what will happen, what from the sensor readings, this will happen, that might happen. So that logic should be built up by you. Then you can use the AI tools to formulate the syntax and get the code done. So this thing you have to try. Okay. So this is something for you, right? So this is a project. This is the first project. If you have any questions regarding this, any question? Yeah. No? Okay. So then I will just move to the next one. Right. Now the next project is distance measurement and alerting. Now go through the part. This project is a simple distance detection system using an HCSR04 ultrasonic sensor and a microcontroller Arduino. It continuously measures the distance of object in front of the sensor using ultrasonic waves. When the detected distance falls below a set, right, the system activates an alarm by triggering a buzzer and flashing LEDs as visual indicator. This demonstrates real-time sensing and result-based control commonly used in basic automation and safety application. Right. So there's a paragraph for you to read. Right. Basically, uh, what happens is there is an ultrasonic sensor. What it does is it always reads the distance in front of it. Let's say you have a wall here, right? You have a wall. You have the ultrasonic sensor here. Now this distance is a constant, right? This is fixed. This is fixed. The wall is also anyway fixed. So this distance is a constant. This distance is continuously measured by the ultrasonic sensor, and when if somebody crosses this, the wave stops here, and the distance reading changes. Right? That change should be perceived by the sensor and alerted to the user. That means somebody has crossed from this point. So that is the basic idea. So detecting that is the purpose of the project, right? When the detected distance falls below a set threshold value, the system activates an alarm by triggering buzzer. So the buzzer also should be triggered, and LEDs should be flashed. So that those are two easy things that you can do. As usual, this demonstrates real-time sensing. So it's a real-time. So uh, the sensor is working continuously. As soon as somebody passes through it, the alert comes. And threshold based control commonly used. Okay. Then similarly as the uh, previous project, you have the stuff that you require, the microcontroller, Arduino, and obviously ultrasonic sensor HC-SR04. Then a buzzer is required that is not shown here that you can connect it, and LEDs, then resistors for you, the breadboard, and the power supply. So those things are same as the previous project. Okay, so this also is something that you have to do. You have to code it, you have to plan it, you have to follow that project life cycle thing, and if you can, I mean, just buy the stuff if it's possible. You can just buy the stuff and put some effort in making it in the real context. But if it's not so, there's a software named Tinkercad. You can use it, you can play around with it. Just connect the stuff in that. There's not this the Tinkercad. Uh, you can make the setup, you can make the project in that virtually. So that is also a good thing. Knowing about simulation software, simulation tools. So just try using Tinkercad also. Then you can just make both the projects if you cannot buy the stuff. Right. So do you have any doubts regarding the two projects? No doubts up to now, right? If you have any questions, just let me know. If you have any questions, let me know. Okay, since there are no questions, I doubt whether you understood everything that I told you. I don't know. Okay, in the process of the project as well, if you get any questions, just you can maybe message me or anything, right? So just ask me when it's needed. Then we have come to the end of the session for today. So I think things we learned, I think you understood them from the beginning, right? So you had some extra stuff as well that might be important for your future. So that is the end of the session. So thank you for joining. So there are around 10, 12 participants. Thank you very much for joining today's session. I hope everything is clear, and if you have any questions, just let me know, right? Okay, so thank you very much. Yeah, I will give you a chance to ask questions if you have. Yes.
Start the damn video. Shit. So I would like to say the vote of thanks. Good evening, everyone. As we come to the end of CYBOTS 2026, session 4, it is my privilege to deliver the vote of thanks. First and foremost, I would like to express our sincere gratitude to our mentor, Mr. Lakindu Mathararachchi, for sharing his valuable knowledge and guiding us through motion detection and alarm systems. Your insights and clear explanations made today's session both engaging and informative. I would also like to extend our appreciation for the All Royalists Engineering Professional Association, OREPA, for their continuous support, and to the Royal College Community Society for successfully organizing this session as a part of Tesseract 26. Big thank you goes to all the participants for your enthusiasm, active participation, and commitment to learning. Your engagement is what truly makes these sessions meaningful. With that, I conclude the vote of thanks. We hope to see you all in the upcoming sessions. Thank you.